Hi guys, this is Joy. Today I'm gonna show you how to analyze a circuit or taking into consideration the resonance characteristics of LC components in a network, the bandwidth, the sensitivity, the resonating frequency, etc., etc., and what are the basic aspects and features of resonance. Now, before going into details, I will tell something that in previous lectures, solving characteristic impedance theorem problems, we have been considering the network synthesis part. That is, we have a network and we have an input. We are finding the outputs, analyzing the network. Now we will consider the network analysis part, and which is a very interesting part. We need to find out the proper resonance characteristics of a series RLC network, and I have taken for this into consideration that a simple 1 ohm resistor, 1 microhenry inductor, and 1 microfarad capacitor with an input of 20 volt RMS. Now, for making this analysis proper, we will go into the grapher, going to AC analysis, AC analysis, choose this start and stop frequencies properly. That is, I am going to take 10 kilohertz to 1 megahertz. Sweep type is decade, vertical scale is logarithmic, rather I take it linear. Output variable is what? Output variable is the current through R1 resistance. Add this one, remove IC1, and then simulate it. You can get the response from here. It is two parts. One is magnitude, another one is phase. I don't need phase right now, so I'm gonna eliminate this. And as you can see, the response from here is a simple resonance characteristics. And to measure the proper resonating frequency, that is peak up here, the current peak up here, we will simply take cursor. We will simply take the cursor by clicking here, show cursors, take cursor back here, and here you can see the resonating frequency to be 158.627 kilohertz. That is right here. And what is the voltage present at this? Is Y2 is 999.624. Y2 and X2, it is cursor 2, as you can see. It is cursor 2. So if you find what is X1 and Y1, it is cursor 1, that is here. It is X1 and Y1. You can also find the slope between these two cursors presented by dy dx. That is here. These two cursors, slope between these two cursors. If you move here, it is made negative as it is sloping downwards. Now we will make one thing. We will remove this resistance and short this path directly to the source. What is the expected output? The expected output is we can get a more sharp response of the resonance characteristics. That is, sensitivity will be more, bandwidth will be less, because what we have simple effect of resistance on resonance. If we increase the resistance of a simple circuit, the curve gets flattened up, and consequently the spreading up of this curve, the bandwidth gets increased, and hence adjacent channel interference gets more and more into the circuit. So it is not a desirable case. So we are gonna eliminate this resistance and analyze this circuit with the same characteristics. That is, start frequency 10 kilohertz, stop frequency 1 megahertz, sweep type decade, and vertical scale linear. Output variable is simply, it will be IL1 or IC1, rather, same series circuit. As you can see, It is again, I am going to eliminate this phasor part. I am considering only this amplitude part. And if we add the cursor here, at this peak point, you can find it to be 158.354, which is very near to this which was 158.627. It is here 158.354. It is very near, and you can see the voltage that is been shown, that is 118.86 volts, but here the voltage is how much? The voltage is 999.624 millivolts. That is the important part, millivolts. As I said, that the more amount of resistance incurred in the circuit, the curve gets flattened up, because the curve gets lowered in its amplitude, gets flattened up, and the bandwidth, effective bandwidth, gets increased. As you can see, as a consequence of flattening the curve, the bandwidth gets increased, and you can consequently infer from here that as bandwidth gets increased, so adjacent channel interference will be more, and it will not be an efficient use of receiver in communication systems. So the resistance should be less and less in order to get lesser bandwidth and lesser adjacent channel interference. And if you want to check whether this frequency has been properly selected or not, you can simply take this formula 1 by 2 pi root LC from calculator. You can simply compute 10 to the power 12 square root this one, and then divide it by 2 pi. Is not matching the result. Let's do it again. 10 to the power 12 to the power half, that is square root, divided by 2. As you can see, it is 159.235 point this one, so 159 kilohertz, and we have found here 158 kilohertz from the graph, that is 158 kilohertz. That is totally dependent upon the positioning. Proper position leads to proper result of the cursor. So I hope you have understood about the resonance very well, and if you have any queries, please post it in the inbox or comment box. That's all for today. See you next time.